Hey guys, George at SoundTraxx here, and this week we are very excited to be able to announce our 8-function 21PNEM8. Now this is an improvement over our previous generation 21-pin decoder with only 6 functions. This is just another way we continue to improve the Tsunami2 product line, Model Railroader's Reader's Choice Award winner for Favorite Sound Decoder 2 years in a row. Now, as a way of doing this, I've installed this along with one of the Nick's Trains decoder buddies into this InterMountain Tier 4. So basically, I've taken it, put it on the track, tested it, it works. So today we're going to set this thing up the way I set up my locomotives so that hopefully maybe you can get an idea on some ideas to set up yours. Now, first thing first, of course, with any decoder as we put it on the track, the default address is address 3. So we're going to go ahead and change this address to the one on the cab, 3888. And yes, we can do this on the main line. Now remember, programming on the main line is no different than sending a function command, which means that command is intended only for the decoder address that you send. So when you're doing this, and especially changing an address, you want to make sure that you only have one decoder on your layout that's set to address 3. Or whatever address you're trying to change from one to another address. And this goes for any other CVs that you're making as well. Make sure that that's the only decoder on the layout that's responding to that address. Now, this is the only one on the layout that's responding to address 3, so we're going to go ahead and change this on the main line to locomotive 3888. So I'm going to walk you through what we're doing here. So we're going to push the program escape button one time, and you're going to see program on main. We're going to hit the enter button. We're talking to Loco 3, so we know that's the locomotive we're talking to, so we're going to go ahead and hit enter. If you were talking to a different locomotive, for example 1575 or whatever, this is where you would want to enter that value in. But because address 3 is what we're talking to, we're going to go ahead and make this change. Now we press enter. Now 1 equals address, 2 equals CV, 3 equals CFG for configuration. We're going to go ahead and change the address, so we're going to push the 1 key. Now it's going to ask us long or short. In NCE lingo, this is the same as a 2-digit or a 4-digit, or in standard DCC, a basic address or an extended address. Now we're going to set 3888, so that's a long address. So we're going to go ahead and push the number 1 for our long address. Now this is where we type in our long address, 3888. Now we press the enter key, and you can see now we're talking to locomotive 3888. Now when I blow the horn, you can see that that decoder is responding. So that's how you change the address on the main line. Now the next thing we're going to do is we're going to go ahead and change the sound so that we can match this Tier 4 GEVO. So the first thing we're going to do is we're going to change the air horn, and we're going to set the air horn, which is stored in CV number 120, we're going to set this to a value of 7, and this is for the K5LH air horn. So we're going to walk you through this process, and then from here on out you'll be using the same process to set the CVs accordingly. So now we're going to program escape button, see program on main, we're going to press enter. Now you'll notice we're talking to 3888, so we're going to go ahead and hit enter. Now this time, instead of hitting 1 for address, we're going to push 2 for CV, and you're going to see enter CV number. This is where we're going to type in 120, enter. Now we're going to change our value, and as I mentioned, the value is going to be 7. So we're going to push the 7, and we're going to press the enter. Now we can use the escape button to get out. Now listen when I blow the horn. You can see how that air horn has changed. That's different than the one we blew a minute ago. So now we work our way through the sound selection reference that you're going to find on our website at SoundTraxx.com. So the next choice is going to be the bell, and that's stored in CV122. Now you're going to go through, now the default value on this is 36, which is the electronic prime bell. Now one thing you can do with the Tsunami2 is once you have your bell selection, if you want that bell to trigger automatically when the air horn is blown, you add 128 to that value. The reason is then that tells the decoder that this is a grade crossing bell, so it will play when you blow the air horn. The default value is 36 to select the Graham White electronic bell. So what we're going to do is we're going to take the value of CV122 and we're going to add 128, so that way we get the grade crossing bell. So now we're going to take CV122, we're going to enter a value of 164, which is 128 plus 36, which is our bell. So now when I blow the horn, you can hear that E-bell automatically trigger. Now next up is our prime mover, and this is stored in CV123. We have a GE collection of different prime movers from the GE family that we can select. Now GE didn't have a whole lot of variations throughout the years, and so they typically stuck with that FDL, tried and true block. But in this case, this is the GEVO Tier 4, so when we look at our list, we're going to select prime mover number 7. So what we're going to do, again, we're going to program on the main CV123 to a value of 7, and you're going to instantly hear that prime mover restart. And now you're going to hear that prime mover start. And this is the specific Tier 4 prime mover that we've added to our GE decoders. Now next up we're going to look at is the air compressor. Now the air compressor, as you hear right there, is the standard GE whooping, but of course the GEVO had a whole different style. So we're going to take CV124, and we're going to go ahead and set this to a value of 2, and that's going to select the GE GEVO air compressor. And you can hear that it's already changed. Now that sound you just heard is the sound of the air dryer, and it's on by default. This is stored in CV125. Now the air dryer is a sound you're going to hear on a lot of the later versions of locomotives. For example, some of the modern GEs, something like the SD70s, SD60s, and even has been retrofitted into some. But on the early locomotives, they had what was called a poppet valve or a spitter valve. And basically what happens is that when that air is compressed, moisture condenses, and that water has to be dispelled out somehow. In the prior generation, it was just a poppet valve, so it would and it would spit out. But more modern equipment has an air dryer, so it has a whole different sound. Now, as we've talked about in the past with our Tsunami2, this sound is actually working in conjunction with the sounds of the air compressor, and the air compressor sounds are working in conjunction with the use of the brakes. So all of our sounds are built in interactive to make sure that you get the best experience. So what happens is when you use your brakes more, the compressor cycles more. When the compressor cycles more, you'll hear different sounds from the air dryer and the poppet valve. So now that we've selected our locomotive profile, now let's go ahead and play with the lights. Now F0, as you can see, is the headlight on in the forward direction. Now when I start to move in the forward direction, you see that the locomotive is moving, the light stays on. When I change directions, you notice that the light goes out, and when I start to move in the reverse direction, you'll actually see the reverse light on. Now on my locomotives, my headlight and backup light I set up to be independent control. We're going to do that here in a minute. But first we're going to go ahead and set all the lighting effects all the way through. So the next up we have Function 24, which is our FX3 lighting output. And that turns on our ditch lights, so you can see that the ditch lights are turned on. Next up is Function 25, and that turns on our number boards. Now these number boards are pretty dim, so they're a little difficult to see in this particular lighting aspect. Next up is Function 26, and that's going to turn on our truck lights. Now our truck lights, you can see, are really bright in this case, and we're going to tone them down here in just a second. Now Function 27 turns on my step lights and my walkway lights. And then Function 28 is where we've assigned, by default, the FX7 and the FX8 lighting effect. So when I turn on Function 28, you're going to see both a blue light and a red light illuminate in the cab. Now this is the default function mapping with everything on. So what we're going to do is we're going to go ahead and change the lighting effects on each of these lights. So first up, for my headlight, we'll go ahead and turn all these other lights off for the moment. We're going to focus on these one at a time. So first off, our headlight is set up by default as a value of 15, and this is set in CV49. And what this does is this is what's called a diesel light, and what it's doing is it will gradually increase the brilliance of that light as that element warms up. Now, one other factor we're going to do is these are all LEDs, which means they have different illuminating properties. So when I turn on and off this light, you see a very instant brilliance of that light. But in reality, it actually is supposed to be a little bit graduated. Well, the reason for this is because this is set up for a light bulb. So what we're going to do is we're going to take that default value and we're going to add 128 to tell this particular decoder that you're illuminating an LED, and it will change how that light illuminates. So we're going to go ahead and do this now. So we're going to take CV49 and we're going to set it to a value of 143, which is 15 plus 128. Now, right this second, you can't see the difference. But when I turn off the light and turn it back on, you can see that it's fairly quick, but it's still a gradual increase. The other thing this does is when we use the F7 to dim the light, you can see a more drastic change in the brilliance of that light versus when it was set up for a light bulb. Now that dim setting right there is adjustable via CV63. So you can adjust that value up and down, and it will adjust the brilliance of the dimmed headlight so you can get just the brilliance you're looking for. So we can do the same thing with CV50, which is our reverse light on our locomotive. So we're going to go ahead and take CV50, and we're going to set that to a value of 143. So now our headlight and backup light are dimmable LED diesel lights. Now next up is our ditch lights. And our ditch lights, we don't want them to dim. So for example here, we're going to turn off our headlight, but we're going to turn on the ditch light. Now when I hit the F7, you notice that they dim, but not by much. But we don't want those to dim. So what we're going to do is we're going to take these to an on-off light, non-dimmable, for LEDs. Now you're not going to notice much difference in this, if any at all, but it's good to add that LED compensation in there because it changes the way that the signal is being sent. So in this case, this is the FX3 lighting effect. So I'm going to take CV51 and we're going to set that to a value of 128, which is a strictly on-off non-dimmable light with LED compensation. So we're going to go ahead and turn that off. Now we're going to look at our number boards, and as I mentioned, these number boards are fairly dim already. So what we're going to do is we're going to leave these kind of the way they are, but we're going to turn them again to an on-off dimmable or on-off non-dimmable, just like our ditch lights are, because these particular lights are a little dimmer. They're going through a little bit more plastic, so that light tends to get lost a little bit. So now we're going to take CV52. We're also going to set that to a value of 128. Now, if you have lights that are very bright, you can adjust these down to be a constant dim, and you can adjust the brilliance, which we're about to do here for the truck lights. So we're going to go ahead and turn on the truck lights. And as you can see, this is a fairly bright light right here. The purpose of the truck lights is to look straight down onto the ground so that at night, when the engineer throws the throttle in, he can look down and see that the ground is actually moving. But these aren't this bright. Now this is the brilliance of typically what you might expect a headlight to be. So what we're going to do is we're going to go ahead and take CV53 and we're going to set that to a value of 147, which is 19 for on-off brilliance register 1. Now you can see how that light has changed and has gone dim. Now we can take this light and we can adjust the brilliance using CV61. So I can take CV61 and we're going to crank it up so you can see how the light has gone up quite a bit, but we're going to take it down. So we're going to take CV61 down to, say, a value of 50, because we don't want that light to be so bright and overpowering that it looks like it's a headlight shining directly down. Now the next light, we're going to go ahead and turn those off. Now the next light we're going to do is going to be our walkway lights and our step lights. And on this locomotive, I've actually wired 8 LEDs into the FX6 lighting output. Now stay tuned to and subscribe to our YouTube channel for a video on how I did that, coming up soon. But what we're going to do is we want to knock the brilliance down just a little bit. So what we're going to do is we're going to set this is CV54, and we're going to set this to a value of 148. And that's 20, which is on-off brilliance register 2, plus 128 for LED. So we're going to set that value at 148, and that's going to dim those lights just a little bit. And now we can take CV62 and we can adjust that brilliance up and down to match the locomotive. So we're going to take CV62, we're going to set it to a value of 100 right now, which will knock a little bit of that brilliance off, but it'll still give us a good brilliance of light when the lights are out. So this is a really good effect right here, and I'm happy with that. So we're going to go ahead and turn that guy off. Now the next two lights, the FX7 and the FX8, are both mapped to F28 at the moment. So for the moment it's going to be a little tough to see the distinction between the two, but we're going to walk you through the process anyway. So we're going to go ahead and turn on Function 28, and you can see the blue, which is going to become a Fred for a blue light for men working, and then we see the red emergency, which will tie into the emergency stop, and we're going to talk about how to do that next. So first up, next is CV55, and that's for the red light that we have set up for emergency. Now again, because this is going to be a constant on without dimmable, we're going to go ahead and turn the function 55 again to a value of 128, because we want that bright light inside the cab, so that way the crew quickly knows that this is the one that's in emergency. Now the next one is CV56, and that's going to be the blue light that you see in the cab, the window there. Now what we're going to do is we're going to set this light to a value of 139, which is 11 to select my Fred, flashing rear end device, it's just a flashing light, plus 128 to tell it it's an LED. So we're going to take CV56, we're going to set it to 139, and now you can see how that blue light flashes. Now you can adjust the flash rate in CV59 for your personal taste. Higher values equals a slower flash. So we're going to go ahead and take CV59 and we're going to set this to a value of 4, which will be a little bit of a slower flash, and so that's kind of a good effect right there. I'm happy with that, so we're going to go ahead and leave that way. So we're going to go ahead and turn the lights off at the moment. So now when we talk about function mapping, this is where we're going to determine which buttons control the lights on and off. We've just set the lighting effects in the CVs as we've just done. Now we're going to tell the decoder what function commands we want to turn those particular lights on and off respectively. So a little bit of background of my models, and we're doing this for one of mine, but you can use this, and this just gives you an element of the flexibility that we have built into the Tsunami2 decoder. So when it comes to my locomotives, in the real world, I'm trying to mimic that as much as I can. The engineer doesn't typically turn off the headlight and turn on the backup light when it's doing a switching move. And so that way, with independent control in both the headlight and the backup light, it gives me a lot more flexibility to be able to control the lights, so that way I can have the lights turn on based on what the real prototype would be doing. So to do this, we're going to get into our flex map function mapping. In this case, it's CVs 1.257 to 1.264, and we're going to go ahead and play with these right now. So to do that, we're going to first take CV32, we're going to set that to 1, and that is the 1 dot part of the CV number. So now when I program CV257, 258, 259, all the way up to 264, the decoder knows I'm talking to 1.257, 1.258, and 1.259, just like I would want to. So in this case, we're going to take 1.257, and that's defaulted at a value of 0. I want to leave that because that's my headlight. But CV 1.258 is my reverse light. And remember, I want to have independent control of these in either direction regardless. So what I'm going to do on my models is I take the backup light control and turn it on with function 28. Part of the reason I do that is because function 28 it requires multiple button presses on most DCC systems, and it's not very often you see the reverse light on a locomotive unless you're doing switching moves or a turn, in which case you may run long hood forward. But a lot of these modern ones, you're not going to see that much, so that's why I have access to function 28. So what I'm going to do here is I'm going to take CV258, And I'm going to set this to a value of 28. And what that does is that tells the decoder to correspond to the 28 key, or the function 28, when I send the command through my throttle. So when I turn that on, now my headlight is on function 0, my backup light is on function 28. But I know you're saying all these other lights in the cab are on function 28 too, and we're going to change that here in just a second. So the next one is FX3, that's on function 24, I leave that alone. The number boards are on FX4, they're on button 25, I leave that alone. The truck lights, FX5, are on button 26, I leave that alone. The step lights and walkway lights are FX6, and they're on button 27, I leave those alone. And so that's how I set up my lights. Now we have two other lights that we want to address. The first one is FX7, which, as I mentioned, is our red emergency light. Now, by default, it's on function 28, but we're going to tie that into the red emergency stop button here on the power cab, and on your SoundTraxx throttle or whatever DCC system you have, your e-stop button normally will send a local command to that locomotive saying, hey, you stop, and then when you push it multiple times, it tells the whole layout to shut down. So this gives you the flexibility to have a lighting effect triggered with the e-stop. Think of those E units and F units that have that red light on the nose of the cab. That's an emergency light, and you can set that up to emergency gyro light triggered by the emergency stop. So to do that, the first thing we want to do is we want to take it off of function 28, and we want to take it out of the function mapping so we don't have any of these other buttons that will trigger that light. So to do this, we're going to take CV 1.263, and remember, CV32 is still set to 1, so all I have to do is take CV 263, and we're going to set that to a value of 255, and that tells the decoder now that no longer any button will control that lighting effect. So now if you look, when I turn on function 28, you notice that the red light is gone. You only see that red flash, and my backup light is on. So now what we're going to do is we're going to take that we're going to take this flashing red or the blue flag, and we're going to tie that to F15. Now F15 by default is the sound of the handbrake, and the handbrake tying down is just a sound effect, but this is a really cool way to add that extra, and we've done a video on this process in a prior video, so be sure to check that out. But now what I'm going to do is I'm going to take CV 264, and again 32 is still set to 1, so that's 1.264, and I'm going to set that to a value of 15. And when I do that, you're going to notice that the blue lights has disappeared because it's no longer on function 28. But now when I tie on function 15, you hear the sound of the handbrake, and now my blue light is back. Now we'll turn off F15, and you're going to hear the handbrake release, and you're going to see the blue flag light go out. Now the last thing we need to do is we need to set up the emergency light to trigger automatically when we hit the e-stop. So we're going to take CV 1.391, which is our emergency stop. Now this is allowing us to trigger lighting effects automatically based on direction, speed, or in this case the emergency stop. So be sure to check out the user's guide for the detailed description on this CV. But what we're going to do is we're going to take CV 391, and we're going to set it to a value of 16. And what that tells the decoder now is that FX7 lighting output that was our emergency light is going to be triggered by the e-stop. So now watch what happens when I hit the emergency stop. You can see that red light illuminate inside the cab. When I change my direction or when I give it a direction speed, you hear that emergency brake release and you see the light go out. Now the last thing we need to do, and you can do this however you like, but we need to set the directionality of all of these lighting effects. Now by default, the only lights that are enabled in directionality or based on direction is the headlight and backup light. But remember, I said on my locomotives I like to have independent control. So CV57 enables each of the lights in the forward direction. CV58 enables each of the lights in the reverse direction. So let's say, for example, when we're moving in the forward direction, we have our ditch lights on, but when we change directions into the reverse, we want to automatically turn those off. Well, what we'll do is then in CV58, the reverse direction, we'll find the FX3 lighting effect and we'll basically disable it or take it out of the total of the CV. Now again, because all of my lights are non-directional, I'm going to set CV 57 and 58 to a value of 255. Now when I start to move in the forward direction, I turn on my headlight, you can see the headlight on. When I change directions and I start to move in the reverse direction, you still notice that my headlight is on. That's because now I've enabled that light in both forward and reverse. So there's no overriding. Now again, you can set this up for your own personal locomotives, but I'm just taking you through a tour of my personal. Okay, so now that we've got our lights set up the way we want, the next step we're going to do is we're going to walk through the dynamic digital exhaust and we're going to address CV114. Now 114 adjusts how many speed steps the prime mover takes to notch up or down. It'll enable what we call an interlock. What this does is this prevents us from accidentally shutting off our prime mover while we're running, and also prevents us from running the locomotive before the prime mover has actually started. The next thing is the auto start. So what happens is as soon as track power is applied, you'll hear the prime mover start up, just like this. So as soon as track power is applied, you can hear that locomotive start up. That's embedded in CV114. Now on my locomotives, I disable that, so we're going to take that out of the mix. The last thing is it adjusts how the prime mover is addressed or changed when we implement our dynamic braking. So in CV114, one thing I recommend is if you're going to use the dynamic exhaust, which we're going to talk about and set up here in just a second, if you're going to use that, I recommend putting the notching at 15. And what that does is it spaces out the auto notching so that allows the dynamic exhaust a little bit more play to make sure that it stays more even keel and not reactive to minute changes in either your grade or your coupler bumps or anything like that. The next thing I do is I enable the interlock. Now, as we've mentioned with the Tsunami2, we have an auto manual notching on our diesel decoder. So as you increase the throttle, you're going to hear that prime mover notch up. But if you want to notch up or down overriding, you can push the F5 to go up and the F6 to go down. So this gives you the ability to have a little bit of manual control as well as the automatic. So with the interlock bit enabled, this prevents me from accidentally trying to coast, bring my prime mover all the way down to idle and then shut off before I'm actually stopped. So the interlock bit says as long as motor power is applied, you cannot shut off the prime mover. Now the last thing is, this is one of the modern locomotives, and based on what I've understood, a lot of the modern ones, when you go into dynamic braking, the prime mover drops down to idle. And so in this case, we're going to add a value of 64 to then force the prime mover to idle. Now, when I'm setting up CV114, I also disable the auto start, which is a value of 32. So when I add 15 for my notching, 16 for the interlock bit, skip 32 so I don't add that, and then I add 64 for my prime mover to idle, I come up with a value of 95. So what I'm going to do is I'm going to take CV114 and I'm going to set this to a value of 95. So now when my locomotive is moving, you're not going to hear, I'm not going to be able to shut it off, but also when my dynamic brakes are applied, it's going to force it down. Now the next thing we're going to do is we're going to set up the dynamic digital exhaust. And what this does is this allows you to hear the prime mover change dynamically based on what you're doing with the locomotive. So when you encounter a grade, you're going to hear it working harder upgrade and coasting more downhill. We're going to set that up right here. So these take CV 2.503, 2.504, and 2.512. Now, remember what we talked about when we were setting up the lighting. Our CV32 value is now going to be set to a value of 2 for our 2.CVs. So when I set this, we're going to set CV32 to a value of 2. Now, to set this up, CV 2.503, we want to set to a value of 255 when the locomotive is moving at speed step 1. And the reason for that is it's going to calibrate how much power that motor is using at speed step 1, which is our base minimum speed. And so that way what it's going to do is it's going to plot a point on the graph, and it's going to say, okay, at speed step 1 it needs this much power, traditionally, which is light on flat level track. So to do that, we're going to move our locomotive forward at speed step 1. We're going to program on the main while this locomotive is running 503 to a value of 255. Now when I hit the enter button, the decoder calibrates the motor and puts a new value. So if you were to go back and read CV2.503, you're not going to get 255. You may get a value of 20, you may get a value of 30, you may get a value of 50, depending on what your motor is capable of. Now CV2.504 is going to plot a second point, and you can do this at any speed step. We recommend somewhere around speed step 20 or speed step 30, and what it's going to do is it's going to plot a second point on the graph, and it's going to say, okay, at speed step, we'll say 25, it uses this much. And so the decoder draws a line, and it says between these 2 points, that's the traditional estimated power consumption of the motor, and it uses that as a reference. So with our graph, if we need more power to move the locomotive, the dynamic exhaust processor will then increase the diesel engine RPM. Same thing the other way, when we're going downhill and we don't need quite as much, then the dynamic processor will then reduce the prime mover. So to do this, we're going to move forward at speed step 20. Now we're going to be able to do this here in this short place. We're going to hold this back. I'm going to move up at speed step 20. Now I'm doing this without any momentum in the locomotive because that way we know we're running at the commanded speed. So now before I release, I'm going to have my throttle set to program CV504 to a value of 255. But before I send that command, I'm going to release my locomotive, let it settle in. Now it's ready. We're going to hit enter, escape out, and we're going to stop our locomotive. Now that decoder has calibrated this model's power consumption at speed step 20. So now we have our graph. Now the last part of this is we're going to adjust the sensitivity, and this determines how sensitive the decoder is going to be to changes in the load. So right now that is defaulted as off. So right now we're going to move forward at speed step 2. So when I stop the locomotive, you don't hear any change. Now we're going to set our sensitivity. So for most of the diesel locomotives, I recommend a fairly low value, somewhere around the 20 to 25 range. And part of the reason is we don't want a whole lot of sensitivity because you can get so sensitive that anytime you go over a rail joint or a coupler bump, you're going to start hearing that prime mover notching all over the place, and it really gives a poor effect. So with a low sensitivity, now we can have those locomotives sounding more even together when the couplers are running, and you get a really good effect. So we're going to take CV512 and we're going to set this to a value of 25 just to try it out and see. Now this one is a CV that you're going to adjust and kind of play with it, see how you like it, run it in a couple of locomotives. You may find yourself changing it a few different times, but the good news is you can change it on the fly. So even while you're running, if you think it's too notchy, go and reduce that value down from 25, drop it down to 20, drop it down to 15, or if you don't think it's notching enough, raise it up. So now, to show you how this works, we're going to move the locomotive again at speed step 2. Now I'm going to put my hand on the locomotive. And now you're hearing the locomotive notching up as it's working harder against my hand. Now when I release, you hear that prime mover drop back down now as the locomotive is running light with no resistance. And that's how you set dynamic exhaust. Now you can do this both with diesel and with steam, the same process. I just will tell you that I typically will use higher values with a steam decoder than I do with a diesel decoder. Usually my steam locomotives are somewhere around the 50 to 60 range for sensitivity. But again, you can go as high as you'd like to match whatever you want to do. Now next up, what I'll address is momentum and braking. And momentum is set in CV3 and 4. And what this does, this simulates how heavy or how long it takes a locomotive to jump or get to the commanded speed. Now right now we're running with 0 momentum, so you're seeing instant start and stops. And so that way we want to simulate the mass or the inertia of the locomotive. So again, on my locomotives, I tend to use extremely high values, and part of that helps the dynamic exhaust also play because it takes longer for that locomotive to get to the commanded speed step. So you're going to hear that locomotive working harder as it gains speed, and then once it gets to the commanded speed, now you're going to hear that locomotive prime mover back off a little bit as it's now working to maintain the locomotive or the train. So typically for my acceleration, I like a high value. So my acceleration in CV3, I like a value of 150. And then for my deceleration, again, I use a high value. So I'm going to set CV4 to a value of 225. Now you have 0 to 255. Now, so you can adjust this for your own taste. But watch how long it takes now that I jump to commanded speed step 20. Look at how long it takes for that locomotive to accelerate. Same thing, when I cut the throttle, you see it's taking a while to come to a stop, but listen to how that prime mover has changed on how it sounds. So it gives you a more interactive feel of actually running the locomotive. Now the next thing is our braking. So with our Tsunami2, we have 3 different braking systems in our diesel Tsunami2 decoders. You have the independent brake, you have the automatic brake, and then you have the dynamic braking, which can be an actual functioning brake, and we're going to show you how to do that. So first up is the independent brake, and what does that mean? Well, the independent brakes are the brakes that are actually on the locomotive. These are the brake shoes you see on the trucks, and they're used when the locomotive is running independent or by itself, hustling through a yard, or you can do it when it's switching cars, spotting cars at an industry, but typically you're going to be braking a lot more quickly than you would if you were using the just cutting the throttle. So in CV117, this is where this is set. So in CV117, I'm going to take this and I'm going to set it to a value of 255. And that's going to represent a minus 127 subtracted out of my braking rate. So remember, my decel in CV4 was 225. So when I subtract out 127, gives me basically a braking rate of about 98, which again, they're scalars, but this gives you an idea of what we're doing. So we're going to run our locomotive. Now when I set that, you could see that the locomotive did not move until I released the brakes. So now let's set the brakes, and now you're going to see that it stops a lot more quickly than it did when I wasn't using the brakes. So that's how you can adjust this. Now you can adjust the braking rate to either add momentum or subtract. Again, check the manual for details. This is how I set up my locomotives. Now the next one is what's called the automatic, and the automatic brake is basically the train brake. So on a real train you have the air line that runs from car to car to car, and the air brakes are what actually helps distribute that braking effort between the locomotive and all the cars in the train. Now if the locomotives were designed to just brake that train by itself without that braking effort distributed, you'd wear out the brakes every time you stopped the train. And so that would become a very expensive option. So what this does is every car has its own braking effort. Now the automatic brake works differently. The independent, you do the independent set, it forces air into the cylinders, sets the brakes, brings the train to a stop. The automatic brakes work differently, and that works on a negative air pressure. And what that means is that normally the train line is pressurized up to about 90-95 pounds per square inch throughout the entire train. So all the way through that train line, there's 95 pounds of air. So when that air is fully set, the brakes on all the cars are now retracted. So when you reduce the air pressure, the brakes will actually grab the wheels of the car and slow it down. Now, part of the reason it's designed this way is if you break an air hose somewhere in the middle of the train, or let's say a coupler broke, well, if you were relying on positive air pressure to stop the train, those cars would be running all over the place themselves. But because they're set up as an automatic with no air pressure, those brake shoes will grab the wheels and bring that cut of cars to a stop. So that way the engineer can now get out and address the train, fix the coupler, fix the air hose, whatever the case is, and get that train back on the road. Now, the braking rate in the automatic brake is set in CV118. And CV118, I typically don't use as high a value, but I do want it to stop the train more quickly than if I was just cutting the throttle, so it allows me to coast. So what I will do is I will set CV118 to a value of 175, which represents a minus 50 from my 225 deceleration. So again, this gives me a little bit of flexibility, but it won't stop my train quickly, but more quickly than if I just cut the throttle. So when I do this, CV118, we're going to set that to a value of 175. So now when I have my locomotive, the first thing I want to do is when F12 is off, I'm set in independent brake mode. So I'm going to turn on my F12, and you're also going to hear the air compressor work as it charges the train line. And you're going to hear the brake system switch over. So my air compressor is running. So we're going to go ahead and run the locomotive again. Speed step 20. We're going to release the brakes. And now you're going to hear a whole different set of brake sounds when we set the brakes. So now you're hearing the air reduction in the cab, and you're going to see how that locomotive comes to a stop. But you're not hearing the squealing on the locomotive. This is where the brakes would be applied on the cars. This is a great opportunity for sound car, because you can set that up so that when you set the brakes here, if you set the values in the cars the same, the sounds will correspond together based on how you're running your locomotive. So when you set up the automatic, you'll hear the air reduction here, but then you'll hear the squealing coming from the cars throughout your train. It's a really cool sound effect. Now the last up is what's called the dynamic braking. And the dynamic braking is actually using the traction motors on the wheels as a regenerative braking system. And what that does is it will then basically take that, and it's the electromechanical resistance of the wheels turning that slows and helps keep that train under control. Well, the sounds we're actually hearing are the fans that are running up out of the locomotive. And so with that, when we press the F4, you're going to hear the dynamic brakes. So when you apply the dynamic brakes in the real world, it won't actually stop your train. It will actually bring it down to about 7 to 10 miles an hour, which is about speed step 10 in our case. So what I do is I set CV116 to a value of 125 because I want to take the maximum amount of time it takes to bring that train down to that slowest speed. So that way I get that high dynamic braking sound all the way through my train. So I'm going to take CV116. We're going to set it to a value of 125. So now, what we're going to do, just to hear it, I'm going to run this locomotive. Now I'm going to apply my dynamic brakes. You're going to hear the sounds kick on. So now I'm going to bring it back. I'm going to hit it again. You hear that high dynamic brake, and now the braking is kicking in. But it's going to take a while for those brakes to bring that train down. But as you can see, it's already slowing down. One more. Now once it gets down to that speed, you're going to hear that high dynamic brake drop down. And now it's just going to maintain that speed as long as the F4 is pressed for the second time. When you press it the third and fourth time to get out, you'll hear that go back. And you hear your prime mover start up, and then your locomotive starts accelerating again based on the speed set in CV3. So that's just an overview of how I've set up my braking and momentum for my locomotives. So in my locomotive setup, the next thing I'll do is function mapping. Now we did this briefly with some of the lights that we started with, but we're going to go through the rest of the list and we're going to move some things around because I like to tend to move things out of where they're at and move them around to what I like personally. Now the good news is you can do this for yourself. So for example, on my locomotives, I like F8 to be my brake application because that way it's a single button pressed on pretty much most DCC systems anymore. If you're using F11, especially like say for example here on the power cab, you have to push the shift key and the F11 to actually trigger it. Same thing with some of the others where you have to hit pound, toggle, whatever. And so this way, by moving F8 to the single button presses, then I can quickly apply the brakes on and off, and I can feather them a lot easier, especially if I'm using the independent brakes. Now I actually have a whole roster of standard settings that you can see right now on my screen. Now what that does is this is a standard function mapping so that way all of my locomotives are mapped the same way. So to do this, and I'm going to have a handy cheat sheet here next to me so I can walk through this process. So first up, when we do our function mapping, these are again in the extended CV. So we're going to set CV32 to a value of 1 to get back to our accessed function mapping. So we're going to set 32 to a value of 1. Now we're going to go ahead and program a handful of these CVs. So to start with, I'm going to start with 274, mute. I normally don't ever use it. So what I'm going to do is I'm going to take that mute and set it to a value of 255. So no longer will a button control that sound effect, or in this case, the mute. Now the next up is CV 1.275. This is our break application. Default value is 11 to correspond with the 11 key. But now that mute is no longer on F8, I'm going to set the brakes to the F8 key. So we're going to take CV 275 and we're going to set this to a value of 8. So now the 8 key is going to be my break application. Now a lot of these are going to be sounds that you're not going to hear on this type of a locomotive. For example, head-end power. This wouldn't be set up for head-end power on a passenger train. So we're going to take CV303 and we're going to set that to a value of 255 because we're never going to use it. CV 1.304 is for cab chatter. You may like that being activated by a function button. I don't, so I'm going to take it out of there and I'm going to rely on Fireman Ed's automatic sounds to trigger a cab chatter sound every now and then. Next up is the coupler sounds. Now this is defaulted on F13. You have couple and uncouple, and the way they work is that they're both on the same button. So when F13 is on, you hear the coupling. When F13 is off, you hear the uncoupling sound. Now again, this is a feature I personally don't use, so I'm going to take both of those and that's going to free up another function button, and I'm going to set them to 255. So I'm going to take 305 to 255 and 306 to 255. Now the next one is all aboard. Now all aboard is on function 23 by default, so that way you can trigger the all aboard sound. Now again, this isn't something I use, so I'm going to take it off. So we're going to take CV311 and we're going to set that to 255. Same thing with our steam generator. Steam generator, this locomotive doesn't have a steam generator, so CV312, I'm going to take that off and we're going to set that to 255. Now the last one here that I'm going to adjust is what's called straight to idle, and this is on function 19. Now as we know, function 10 is straight to 8, function 19 straight to idle. Both of these force the prime mover sounds automatically all the way up to 8 or down to idle, and this allows you a little bit more flexibility if you're coasting into a station stop, or in the case of a straight to 8, you can hear that locomotive working harder as it gets a cut of cars or a train started. So F10 is my straight to 8. I'm going to make F11 now my straight to idle, so they're just one button away next to each other. So I'm going to take CV314 and I'm going to set that to a value of 11. So now my F11 will control that. Now there is one other thing that I do with my locomotives, and it has to do with function 14. Function 14 is what's called switching mode, and basically what it does is there's two aspects to function 14. It does, one, takes the commanded speed step and cuts it into 1/2. So if you're moving at speed step 10 and you enable function 14, it will cut you down to speed step 5 essentially. The other thing it does is it overrides the momentum and basically takes your momentum and turns it off. The reason is if you're doing specific spots for industry or picking up cars, things like that, you can get that instant start and stop feature that you like. Now personally on mine, again, I like to have the momentum on it regardless of what I'm doing, but I do want to keep the half speed for switching mode. So I'm going to take the momentum half of this and I'm going to take it away from the function mapping out of function 14. So I'm going to take CV 1.277 and I'm going to set that to 255. So now when I go into switching mode, I still have my momentum. So me and my engineers have to still have that brake ready because we need to control and stop that train, even though now we'll be running a little bit slower. So if you do the math, if you're running at speed step 1 and you enable function 14, you can be moving at speed step 1/2 with Tsunami2. So this is just one of the examples of the better motor control that we've given you in the Tsunami2. Now we turn it off and we can go back to standard speeds. Now, the next part of my setup I like to do is to set up the volume controls. And this is where you can adjust all of the sounds to match your personal tastes. Now, I'm not going to spend a whole lot of time going through every single volume setting, but first of all, I'll highlight a few. CV128, which is your master volume. Now, on a small layout like mine, typically the volumes are always way too loud. If I can hear that locomotive on the other side of the layout, it's too loud. So what we'll do is we're going to take the CV volume and we're going to set it to about half. So we're going to take it down to about 75 or 80. So you can hear how that locomotive has dropped the volume down. So that's going to be a little bit more realistic tone. Now, each of the individual sound effects has its own volume control as well. So you can control things like the air horn, which again is way too loud. So this is in CV129. You can hear how it's reduced that volume quite a bit. Same with the bell. The bell is way too loud for my personal opinion. We're going to take CV130. We're going to adjust that down to around 60. And you can hear how that's a little bit lower. If you want to go lower still, you can adjust this in CV130 until you find that tone that really works for you. So we're going to take it down to 40. And you can hear how that bell volume has reduced. Now the next one is the prime mover in CV131. And again, these are always way too loud, but I'm going to leave this one up where it is right now because one of the next things we're going to talk about is adjusting the equalizer, and this is where it's really going to shine. But you can go through and adjust each of those volume levels to your personal content. Things like the air compressors and radiator fans, some of those I tend to turn down. And some of the other background sounds that kind of play in the background, things like the pneumatic lubricators, the relays, things like the wrenches, cab door, and yes, including Fireman Ed's toilet flush, you can adjust the volume to that. So I usually take those down to a volume level of about 10 or 20 so that you can hear them and they're there, but when the locomotive is running, you really wouldn't hear them all that loud, especially in a real-world environment, but the sounds are there. Again, if you don't want the sound to be there, turn the volume all the way to 0. So next up, we're going to play with the equalizer a little bit. And the 7-band equalizer really allows you to adjust the overall tone and intensity of individual frequencies so that you can get the best out of this locomotive. Now this is set right now to default values, and what that means is that all those equalizer settings are flat, right in the middle, which means no change, no adjustments, or anything like that. Now, I encourage you to play around with these values and kind of see the way you like it. But the way it works is the CV value for each of those bands has a value of 0 to 255, where a value of 128 is flat in the middle or no change. If you want to boost a particular frequency, you're going to turn that CV up from 128 up to a value of 255, which is full boost. Same thing, if you want to cut a particular frequency, you'll take that down to 0, which will be a full cut of that equalizer value. So we're going to go ahead and play with this, and I have some settings that I tend to like for most of my locomotives, and you may have one for yours, so start there and kind of do some minor tweaking so that way you can have all your different locomotives sounding different, or you may have different settings. So for example, in this locomotive, I've installed 4 of our Minicube speakers into this locomotive. So all 4 of those speakers are working together to really produce that 100 hertz and above frequency. Yes, I did say 100 hertz. So what we can do is we can really get that low end frequency and boost it up so that way it really comes through and shines, especially with these big heavy GE locomotives. So again, I'm going to grab my cheat sheet and I'm going to play along here while we set the CV values so that way you'll be able to see what we're doing. So I'm going to take CV225 and I'm going to set this to a value of 7, which is going to enable my equalizer. Now at the moment, nothing has changed. So the first one is CV226, which is around 62 hertz, which is below what this speaker can actually reproduce. So what we're going to do is we're going to take this and we're going to cut this to 0. Didn't hear much of a change. Next is 227, which is 125 hertz, which is above what we can hear. Now, because these speakers are able to reproduce that, I'm going to boost this frequency up quite a bit. So we're going to take CV227. I'm going to set it to 200. You can hear a very minor change, but you can hear that lower end coming through. You can try to play around with this if we want to boost it up to 225 or 250. You can do that. I'm going to go ahead and boost this up to 225. Try to get a little bit more of that low end frequency. Now the next one is going to be right around 250 hertz, and this is where most of your speakers are actually going to finally come into play and actually be able to reproduce some of the sound. So in this case, I'm going to boost it up, but not by a whole lot. We're going to take CV228, and we're going to set this again to a value of 200. And now you can hear how much stronger that mid-range is coming in now. Now we're going to take 229, which is right around the 500 hertz range. And what we're going to do is we're going to boost this up, but not quite as much. So we're going to take that to about 180. You kind of hear a little bit of that mid-range coming up here. Next up is we're going to set it 230, which is right around the 1000 hertz range, 1 kilohertz. And we're not going to boost this up by much, so we're going to take this to around 150. You can hear a little bit of a change, but again, we don't want to overpower those high frequencies. We want those low tones to really come in and shine. So now these next two, the 2 kilohertz and the 4 kilohertz, we're going to reduce those down a little bit. So we're going to take CV231, and we're going to drop that down a little bit. We're going to set that down to 100. And then we're going to take CV232, which is our highest frequency at 4 kilohertz, and we're going to set that down to about 75. So now let's listen to the air horn. And we can hear our prime mover. Let's put some pressure on that so we can really hear it shine. So you can kind of hear how that's coming through. Now with these settings, let's turn the equalizer off so we can hear the change, the final change. So we're going to take CV225, we're going to set it back to 0. And you can hear that change instantly. And you can hear kind of how flat it got, because again, it is flat. So let's take 225 and let's turn on the user adjustable, which is what we were just playing with. You can really hear that low end coming through. Now is when I would go in and adjust the prime mover volume. So we're going to take CV131, and the default value of that is around 150. So I'm going to take this down to 100, just to kind of reduce it down a little bit so that way it's not overpowering. Now one other aspect of the prime mover that we haven't talked about yet is prime mover pitch shift, and this is in CV223. This allows us to take the overall pitch of the prime mover and slightly shift it up or slightly shift it down. And this gives you another tool that allows you to have the same prime mover sound, but then give it a little bit different output, sound a little bit different, and so forth. So what I'm going to do is I'm going to take CV223 and I'm going to reduce it all the way down. So let's hear the change. You'd hear a little bit of a change. You can hear it drop a little bit. But just for contrast, I'm going to take it and move it all the way up. You can kind of hear how that changed and went all the way up. So I tend to like it down a little bit, so I'm going to take this back down. And we're going to leave it at the lower end. And again, you can adjust this. You may decide you want to leave it right where it is. Again, this is a setting you can play with and adjust and decide for yourself. Now the last thing I'm going to talk about in this setup video is the reverb and echo. And the reverb and echo allows you to have a little bit of tone of depth and atmosphere added into the sound effects on your diesel or your steam locomotives. Now on this particular one on the diesel, I tend to add a little bit of an echo to the air horn only, so that way you get a little bit of a broader depth of sound when the locomotive is running and blowing that air horn, so you can kind of hear that reverberation. So typically what I'm going to do is I'm going to take CV233, which is our reverb control. We're going to set that to a value of 4 for a light echo. Now once we apply that echo, now we're going to determine each of the sound effects has its own channel that you can add reverb and echo into each of those. So on CV161, this determines the percentage of that light echo that's going to be refed back into the air horn sound. So I'm going to take CV161, we're going to boost it up a little bit, so I'm going to take it and set it to a value of 150. Now let's listen to that air horn. You can kind of hear how you get a little bit of that echoing trail. Now again, let's take CV233 and we're going to set it to 0. So now you can hear the difference. You hear that instant drop off. So now when we add a little bit of echo back into it with our light echo, now listen to the air horn. And you can hear how that atmosphere has changed. Now if we go with a heavy echo, you can hear how much more echo and tone off there is. So again, you can adjust this for your personal taste. I like a light echo and a little bit of and a heavy applied, about 70% to the air horn sound for my personal locomotives. So guys, this is a really quick tutorial. There's a lot more that you can set up in the Tsunami2, but this just kind of gives you an overview of all the things that I do to my personal locomotives. So hopefully this has given you a little bit of inspiration of things that you can do and how to set up your locomotives so that you can get the most out of the Tsunami2. Now again, be sure to subscribe to our newsletter and our YouTube channel so that you can make sure you get all these short little video tutorials highlighting specific features that way you can get the most out of your decoders. So guys, thanks again for watching. Appreciate it. We'll see you next time.